Good afternoon, everyone. I'm Thomas Estrada.
I'm Jose Jimenez, and what we're going to talk about in this video is basically about lattice energy and Coulomb's law. Lattice energy is the amount of energy required to separate the ions in an ionic solid. Coulomb's law is basically it lies underneath the electromagnetic forces. It's the repulsion and attraction between charged particles, and in this representation it shows the ionic solid between sodium chloride and sodium fluoride. But before we get into this, we're going to talk about the equations.
So, as you can see here within these equations, these two would yield very similar answers because of the fact of how similar they are. As you can see here, Coulomb's law and lattice energy, they both multiply by a constant, as well as the magnitude of the charges divided by the ionic radius. And the reason this is, as you can see in our diagram, the reason this is significant is because as we showed our boiling points, they would be directly proportional to the required lattice energy to split the atoms, or to separate the ions within the ionic solid. And as you can see here, any sodium chloride has a smaller boiling point than sodium fluoride, as you can see by the boiling points. And the reason this is the reason
this is true is because chlorine and fluorine, right? So if you look at them in the periodic table, fluorine has a smaller quantum principal number. Basically, it has it's closer to the nucleus, so it has a higher effective nuclear charge. So it's more attracted to the nucleus than chlorine is. So it would have, since the distance between the two nucleus is smaller, it would have a greater lattice energy depending on the distance of the two nucleuses, basically.
And as Jose had explained earlier, how lattice energy is basically the energy required to separate the ions in this ionic solid. As you can see here, this is when sodium chloride is in its ionic solid form, and after a certain amount of lattice energy is given, it turns into plasma, which is basically charged particles in gaseous form. Thank you.